Hello everyone, my name is Paritosh and I'm working on a Qt3D based backend for KStars in my Google Summer of Code 2020. My mentors are Mike Cruz and Jason Mutlak, and you can contact me using this. So let's begin. So first I'll start by introducing what a planetarium software is. It's simply a program which simulates the night sky at any location of the Earth at any given time. And there are separate planetarium software such as Stellarium, KStars, SkyMap, formerly known as Google SkyMap. Now there are mostly two parts to these planetarium softwares. The one part, it focuses on getting the data of the positions of the object in 3D or 2D coordinates, and the second part is the drawing part, which actually draws the sky objects from the data. Now, softwares like Stellarium, they are capable of drawing in 3D. However, other softwares like KStars, they currently only use a 2D based backend. For 2D, we have a popular backend known as QPainter, and there was also work on an OpenGL version. Right now, what we aim in this project is to add a 3D backend and which will be based on a Qt3D based framework. So this is a brief overview of how KStars actually draws the sky objects. So as I said, there's a information bit or a data bit and a draw bit. So we have the information in KStars and we have a class known as SkyMap, which is actually the widget on which everything is drawn. So SkyMap actually can use either SkyMap QDraw or SkyMap GLDraw. And this QDraw, this actually is the QPainter based backend widget, and the GLDraw is the OpenGL based backend widget. Again, we have something known as the SkyMap composite, and this is where everything is drawn. This controls the draw calls for each sky object, and this sky object is just a base class for each and everything. This includes planets and comets, moon, everything. The individual classes of these have the draw call, which could either utilize QPainter or OpenGL, and this has been served using a common interface SkyPainter. Now, since the SkyPainter draw calls, which are called in the Sky object class, they occur at every paint event, so we can't utilize Qt3D using this interface. We can't do this. And the reason behind this is because Qt3D utilizes something known as scene graph as its drawing principle, and which basically means you have to give all the information to Qt3D and it will handle the drawing. Thus, the only solution to solving this problem is actually having both initialization and update draw calls in SkyMap composite. And this means each and every sky object they needs to have these two calls. And the initialization call, it will be utilized to use to initialize the scene graph, and the update call will just change the transformation coordinates or anything related to projections or colors. So this was what I suggested in the previous slide. We have a custom window which is derived from the Qt3D window, and each sky object, it has the option to actually modify the Qt3D window, which the custom window we have used here, and this will have calls for everything. This include initializing some sky object, be it a planet or a moon or anything, and even for update calls for all those. So till now we mainly discussed the integration section, that is how to integrate Qt3D inside KStars. Now we are talking about some technicalities related to drawing, as in using that backend to draw in 3D. And this mainly covers two main topics, which is astronomical projections and instance rendering. So we generally, when we use 3D software or we play 3D games, we actually use something known as perspective or orthogonal projection. They, however, don't apply for astronomical softwares. And for astronomical softwares, we have a set of 6 projections inside KStars. These include Lambert or equirectangular, etc. Now, the main complexion was to employ uh, these projections inside the shaders, and when we are drawing it, so instead of the x, y, or z coordinate, which is served in which is given to the s vertex position to the vertex shader while drawing, we have to give the right ascension and the declination of the sky object to the vertex shader, and this will actually project it using one of the 6 astronomical projections, and project them on a 2D screen, and then it is further given to the fragment shader, which handles the coloring, etc. So this was a difficult bit to tackle and was the first problem in the drawing side. The second problem is related to instance rendering. So as KStars, it can have a lot of stars or a lot of sky objects, and we can't draw all of them individually by giving like separate buffers for every time we send shader info to the graphic card. To solve this, we use something known as instance rendering, which is we give all the vertex positions and other shader information in the that is the other shader parameters in just one buffer, and it handles the drawing for multiple objects at the same time. So instance rendering was utilized throughout KStars, and most importantly when we use uh, it to draw stars and the grid. So this can include the grid lines, which are similar to latitude or longitude for planetarium softwares. So for example, for rendering stars, we actually just place the points at the given right ascension and declination for that projection, and then we pass in this happens in the vertex shader, and then we pass it to a geometric shader which just summons a quadrilateral at that particular point, and it has the texture for the star we want to draw, and then it is passed to the fragment shader. Here are the results, and as you can see, we have our sun, we have a few red lines, we have a few stars, and some keyboard and mouse actions are working right now. This includes zooming and uh, panning and changing projections or turning off the particular sky object. Similarly, we have more textures, and we'll add more 3D models for the other sky objects as well. So this was my work, and thank you, and you are free to ask any queries that you have.